This video is a lesson over electrical circuits, resistors, and power. Alright, so for this problem we have a 15 volt battery and that's connected to a 5 ohm resistor and a 10 ohm resistor in series. And we want to find the power from the 5 ohm resistor. So I've already drawn out the circuit here for that. And as you can see, they're connected all in series. There's a couple things we want to go over before we get into this. First is Ohm's Law, which that's a pretty simple equation that we will use a lot actually, and that's voltage is equal to current multiplied by resistance. And we also have Kerckhoff Second Law, and for that one it's all voltages must add to zero in a loop. And what this means is we have our battery, which is a 15 volt battery, and then we have voltage drops from each of the resistors. So what that means is that not actually each resistor will have the same voltage drop. So let's go ahead and write out some other things that might be important since we have a series circuit here. And so for a series circuit, we know that the current is the same throughout the circuit. And also the equivalent resistance, and that's really just means the total resistance, is the sum of all the resistors. So what we can do is we can kind of rewrite our circuit to look a little bit like this. We can basically have it being one big resistor, basically the two added together because they're in series, and that would be equivalent resistance of 15 ohms. So if you say, we have 5 ohms and a 10 ohm resistor, that should give us 15 ohms. So now we can use Ohm's Law here, and we know that V is equal to I multiplied by R, so voltage is equal to current multiplied by resistance. And we can divide by resistance on each side, and we get current is equal to voltage divided by resistance. And now we can take our totals to find the actual current throughout the entire circuit. So we have 15 volts over 15 ohms. And that gives us a current of 1 amp. So now we have our current, and we know our resistance as well for our 5 ohm resistor because it's 5 ohms. But we don't know the voltage, but we can actually get around this, because when you calculate power, it's equal to current multiplied by voltage. Like I said, we don't know the voltage drop for the 5 ohm resistor, but we can use Ohm's Law to substitute in for this. So we can say power is equal to that current, still multiplied by, and then current multiplied by resistance. And that's from Ohm's Law right there. So power is the same thing as current squared multiplied by resistance. So our power for this should end up being, let's see, we have our 1 amp squared multiplied by 5 ohms. Our power should be 5 watts. Okay, so now let's go on to the next part of the problem. And so now we're considering the same circuit but with the two resistors in parallel. And so we want to find the power from the 5 ohm resistor still. So for this one, it's different because, like I said, it's parallel. So you can obviously see that by how I've drawn it. And so there's a couple things we want to go over before we actually get into that part of the problem. So for a parallel circuit, the current is not the same throughout the circuit. So that's a key difference from the series circuit. Also, we know that the equivalent resistance is found differently here. The equivalent resistance, it'd be probably easier for me to actually write out the equation for it rather than try to explain it in words. And what it is the reciprocal of the equivalent resistance is equal to the sum of all the reciprocals of resistances. So I'm just putting the plus dot 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 for, you might have more resistors than 2 in your circuit. But for this one, we actually might not have to find the equivalent resistance, and we might be able to find a way around this actually. So let's go ahead and look at it. We said earlier that Kerckhoff's second law was that all voltages must add to 0 in a loop. So if you think about this, we can think about the loop right here, just including like this left side. And so since our 15 volt battery provides 15 volts, we know that the voltage drop across the 5 ohm resistor should be 15 volts. So if we go ahead and look at that, we can use Ohm's Law, V is equal to I times R, solve for current again, and we should have our 15 volts, but our resistance here is 5 ohms. So our current should be 3 amps. But now since we know our current and we know our voltage here, we actually don't need to find the equivalent resistance. So we can say power is equal to our 3 amps multiplied by our 15 volts, and that gives us power of 45 watts. This has been a lesson over electrical circuits, resistors, and power.